Let us continue exercise 3.3 on integration by parts. In that, the next example is x into sine inverse of x dx. So let I is equal to integration of x sine inverse of x dx. So here, after using the LIATE rule, the first function we choose sine inverse of x and the second function is x. So inverse trigonometry and then algebraic function. Now we will use by parts. First function as it is, integration of the second function minus integration d by dx of the first function into integration of the second function. Now integration of x is x square upon 2. Derivative of sine inverse of x is 1 upon root 1 minus x square. Again integration of x is x square upon 2. So here I will get 1 upon 2 x square into sine inverse of x minus 1 upon 2 is taken common, integration of x square upon root 1 minus x square dx. In next step we will adjust the numerator like this, 1 minus x square minus 1. So this 1 will get cancelled and this minus 1 will make this plus minus 1. So no change in the integral. Then in next step we will divide this root 1 minus x square to this 1 minus x square and minus 1. Okay, after division here you will get root 1 minus x square and its integral is root a square minus x square. Its integral is given by x by 2 root a square minus x square plus 1 upon a square by 2 sine inverse of x by a plus c. So here I will get the integral of x by 2 root 1 minus x square plus 1 upon 2 sine inverse of x minus 1 upon 2. The integral of this 1 upon root 1 minus x square is sine inverse of x plus c. So 1 upon 2 x square sine inverse of x plus, take this 1 upon 2 inside this bracket, you will get x upon 4 root 1 minus x square plus 1 upon 4 sine inverse of x minus 1 upon 2 sine inverse of x plus c. Combine these two terms because they are like terms. So 1 upon 2 x square sine inverse of x plus x upon 4 root 1 minus x square minus 1 upon 4 sine inverse of x plus c, because 1 upon 4 minus 1 upon 2 is minus 1 upon 4. So the integral is like this: I is equal to 1 upon 2 x square sine inverse of x plus 1 upon 4 is taken common from these two terms in bracket x root 1 minus x square minus sine inverse of x plus c. So this is the solution of the given integral. The next example is x square into cos inverse of x dx. Let the integral is denoted by I. Now here again this is algebraic function and this is trigonometric function. So what we will do, we will rearrange these functions as using this LIATE rule. So cos inverse of x is the first function and x square is the second function. Then using the by parts, first function is as it is into integration of the second function minus integration of derivative of the first function into integration of the second function. Now here the integration of x square is x cube upon 3. Derivative of cos inverse of x is minus 1 upon root 1 minus x square, and integration of x square is x cube upon 3. Take the little arrangement here. So 1 upon 3 x cube cos inverse of x plus this minus become minus become plus 1 upon 3 we can take outside. So 1 upon 3 integral of x cube upon root 1 minus x square dx. I will call this integral as I1 and we will solve this separately. Okay, how to solve it? What we will do, this x cube I will write it as x square into x. Then we use the substitution 1 minus x square is equal to t. So x square is equal to 1 minus t. And what is dx? Dx is minus dt upon 2. Use these values in this integral, you will get integration of 1 minus t upon root t into minus dt upon 2. Again here, this minus we can give inside this term, we will get t upon root 2 minus 1 upon root 2, root t upon root t minus 1 upon root t. Then this t I can write t upon root t is nothing but root t. Okay, and 1 upon root t can be written as t raised to minus 1 by 2. So take the integral, we get the integral of root t is t raised to 3 by 2 upon 3 by 2, and integral of 1 upon root t is 2 root t, because it is in the form of f dash of x upon root f of x. Its integral is 2 root f of x. So after simplifying, you will arrive at this stage 1 upon 2 into 2 by 3, 1 minus x square raised to 3 by 2 minus 2 in square root 1 minus x square plus c1. So multiply this 1 upon 2, this integral. What you get? 1 upon 3 in bracket 1 minus x square bracket raised to 3 by 2 minus square root of 1 minus x square plus c1. This is the value of our I1. We will put this value in this integral. So I is equal to 1 upon 3 x cube cos inverse of x plus, now this 1 upon 3, we will multiply this 1 upon 3 to this whatever integral we got, 1 upon 9 1 minus x square is to 3 by 2 minus 1 upon 3 root of 1 minus x square plus c, where c is 1 upon 3 times c1, because we are multiplying this equation by 1 upon 3. So this is the integral of the given function. Now log x upon x. Here it is a composite function, and we know that we cannot find the integration of the composite function. So we have to remove the composite function. Now, how to remove the composite functions? By using substitution. Put log x is equal to t. So 1 upon x dx is equal to dt. 1 upon x dx will be replaced by dt, and here this dx is equal to x dt, or 1 upon x is already it is replaced by dt. So you get log of t dt. Now here the second function we will take as 1 using liate. The second function is not present, so it is we take it to be 1. So log of t into 1, its integral. Keep first function as it is, integration of the second minus integration d by dx of the first into integration of the second. Now 1 dt, its integral is t, d by dt of log t is 1 upon t, and the integration of this dt is t. Log t into t minus 1 upon t, this t2 will get cancel and 1 will remain only. Its integral is minus t. So what is the integral? I is equal to t log t minus t plus c. But what is t? T is nothing but our log x. So log x into log of log x minus log x plus c. Or you may take this log x common. Okay. So in bracket we will log of x in bracket log of log x minus 1 plus c. Now if you see this example, t sine inverse of t upon root 1 minus t square into dt. Now, we have already studied how to use the substitution method. We will search a function in the integrand whose derivative is present in the integrand. So here clearly the derivative of sine inverse of t is present. So we have to substitute sine inverse of t is equal to x. So 1 upon root 1 minus t square dt is dx, and the value of t is sine x. So 1 upon root 1 minus t square dt will be replaced by only dx, and t is sine x, and here I will get sine x into x dt. So using LIET rule, the algebraic function must be taken as a first function and then a trigonometric function. So x sine x dx. Then using by parts, first function as it is, integration of the second function minus integration d by dx of the first function into integration of the second function. So here integration of sin x is minus cos x, derivative of x is 1, integration of sin x is minus cos x, so minus minus it becomes plus integration of cos x. So again integration of cos x is plus sin x plus c. So I is equal to minus x cos x plus sin x plus c is the integration of the given function. But what is, already we have substituted sin inverse of t is x. So again we have to back substitute the value of x. How? The x is sin inverse of t. So minus sin inverse of t into cos of sin inverse of t plus sin of sin inverse of t plus c. But sin of sin inverse of t is nothing but t. So minus sin inverse of t into cos of sin inverse of t plus c is the integration of this function. Now moving further, look at this example. Cos of root x. Now already we have solved this example in our solved example. So you can go through this example. Already I have explained it in the solved examples, how to solve it. Very simple. It is a composite function, so you have to use the substitution. Root x is equal to t, so 1 upon 2 root x dx is dt. So dx is 2t dt. Then use the by parts. Now here sine theta log of cos theta d theta. This is the function. So in this function, let I is equal to this. So again we have to use the substitution. Cos of theta is equal to t. So its derivative minus sine theta d theta is dt. So sine theta d theta is minus dt. This sine theta, this d theta is minus dt, and you will get log of t minus dt. So log of t minus 1 dt, log first function as it is, integration of the second, minus derivative of the first function log t into integration of the second function, that is minus 1. So integration of minus 1 is minus x or minus t because it is with respect to t. Then the derivative of log t is 1 upon t. Integration of minus 1 is minus t. Here tt will get cancelled and here minus 1 will remain. This minus 1 and this minus 1 becomes plus 1. So minus t log t plus integration of 1 dt. But the integration of 1 dt is nothing but t plus c. Now what is t? Because we have substituted the root x is equal to t. So t is root x. So we will put here t is equal to root x. Sorry, the root x is for the previous example. For this example our substitution is cos theta, so put t is equal to cos theta. Okay, so minus cos theta log of cos theta plus t is again cos theta plus c is the integration of the given function. You may take this cos theta common, or this plus cos theta I can write it firstly, and this then is negative term cos theta minus cos theta log of cos theta plus c. Now integration of x cos cube x dx. Again here it is a product of two functions, but cos cube of x, I will write it as with the help of cos 3 theta. Cos 3 theta is nothing but 4 cos cube theta minus 3 cos theta. So using cos triple angle formula of cos theta, cos cosine, triple angle formula of cosine, you can write this like this. Then we can divide this numerator by this 4 separately, then multiply each of this term by this x. So we will get the two integrals, 3 upon 4 integration of x cos x dx plus 1 upon 4 integration of x cos 3x. So call this integral as I1 and this integral as I2. So take I1, so it is in the form of LIT rule. So first function as it is, integration of the second function minus derivative of the first function into integration of the second function. Now integration of cos x is sin x minus derivative of x is 1 and integration of cos x is sin x. So I1 is x sin x minus integration of sin x dx. Now here the integral of sin x is minus cos x plus c1. So I1 is x sin x plus cos of x plus c1. This is your I1. Now think of I2, integration of x cos 3x. Again use the by parts x as it is, integration of cos 3x minus dy dx of x, integration of cos 3x with respect to x. Then integration of cos of 3 theta of cos 3x is sin 3x upon 3. Derivative of x is 1. Again integration of cos 3x is sin 3x upon 3. So 1 upon 3 x sin 3x minus 1 upon 3 sin 3x dx. 1 upon 3 x sin 3x as it is. Then here 1 upon 3 as it is. The integration of sin 3x is minus cos 3x upon 3. So here minus minus become plus, and 1 upon 3 into 1 upon 3 is 1 upon 9. So this is the integration of the second function. We will use these two integrals in our first integral I. You get 3 upon 4 x sin x plus cos x plus 1 upon 4 x sin 3x upon 3 plus cos 3x upon 9 plus c, where c is 3 by 4 c1 plus 1 by 4 c2, because for first integral we are multiplying by 3 by 4, so 3 by 4 c1, and in second integral we are multiplying by 1 by 4, so we here will get 1 by 4 c1, 1 by 4 c2, sorry. So the integral is, we can take 1 upon 9 common from this two, so we get 1 upon 36, 3x sin 3x plus cos 3x plus c. So this is solution of this 17th example. Now the next example is sine of log of x bracket square upon x. Now here we have to use substitution, log of x bracket square is equal to t. So its differential will be log of x upon x dx is equal to dt upon 2. So log of x upon x dx will be replaced by dt upon 2. So our new integral will be integration of sine t dt upon 2. So 1 upon 2 we can take outside, integration of sine t, and integration of sine t is minus cos t plus c. But what is t? T is log of x bracket square. So minus 1 upon 2 cos of log x bracket square plus c is the integration of the given function. 19. Log integration of log x upon x dx. So I is equal to integration of log x upon x dx. So put log of x is equal to t. So 1 upon x dx is equal to dt. Therefore I is equal to integration of t dt, and its integral is t square upon 2 plus c. So what is t again? Log x. So the log of x bracket square upon 2 plus c is the solution of this integral. Now the next example, x sin 2x cos 5x dx. Its integral we have to find out. So here we will make an adjustment, multiply divided by 2. So here 2 sine a cos b, defactorization formula will be used here. Sine of 2x plus 5x plus sine of 2x minus 5x is sine 7x plus sine of minus 3x. This is the formula. So then multiply this two terms by x and separate the integrals. You will get two integrals. 1 upon 2 x sine 7x dx minus 1 upon 2 integration of x sine 3x dx. So the first integral is I1 and the second integral is I2. Now take the first one, x as it is, integration of the second minus derivative of the first, integration of the second. After taking the integral, you will get the integral I1 as minus 1 upon 7x cos 7x plus 1 upon 49 sin 7x plus c1. This is I1. So I can write it as 1 upon 49 sin 7x minus 7x cos 7x plus c1. Now just start to solve the I2. So I2 is equal to x sine 3x. So again I use the first function as it is, integration of the second function minus integration dy dx of the first function into integration of the second function. Take the integrals and simplify it. You will get the I2 as 1 upon 9 in bracket sine 3x minus 3x cos 3x plus C2. Now use these I1 and I2 in I. You get I is equal to 1 upon 2 times I1 minus 1 upon 2 times I2. So 1 upon 98 sine 7x minus 7x cos 7x minus 1 upon 18 sine 3x minus 3x cos 3x plus C, where C is equal to 1 upon 2 C1 minus 1 upon 2 C2. Okay, so the next example, cos of cube root of x. So let I is equal to integration of cos of cube root of x dx. Now here it is a composite function. So when we have to use the substitution, cube root of x is equal to t. So taking the square of both the sides, so we get t square is equal to x raised to 2 by 3, or x is equal to t cube. So dx is 3t square dt. So here we got the integral of the form 3 into integration of t square cos t dt. It is in LIATE form. So keep the first function as it is and integration of the second minus integration of derivative of the first one minus integration into integration of the second one. So integration of cos t is sin t and the derivative of t square is 2t. So in next step we have to find the integral of t sin t dt. So again Li using LIATE, the first function as it is, integration of the second minus integration derivative of the first function into integration of the second function. So in final stage you will reach to the, you have to find the integration of cos of t, it is sin t dt. So multiplied throughout by this you will get I is equal to 3 times t square minus 2 sin t plus 2t cos t plus c. But what is t? T is cube root of x. And what is t square? X is to 2 by 3. So 3 in curly bracket, in round bracket, x raised to 2 by 3 minus 2 into sine of cube root of x plus 2 into cube root of x into cos of cube root of x plus c. Okay, so this is exercise 3.2. Again we will meet on the same exercise for solving the further examples. Now we will stop here.